Alright, it looks like we're live. So, good evening everybody from a beautiful Death Valley region of California. Got a beautiful, calm, clear night for the first time in a little while actually. And it's been warm but cloudy and breezy here, so we finally got a nice clear little night, which is great. Tonight, well, we're going to be doing some maybe a little bit of everything. I don't know. We'll kind of go as suits our fancy. I think what we'll start off with here is probably the Pleiades. The Pleiades is a nice. Oh, come on, grab. Got to get this window reset, and this window won't move. Why will this not move? There we go. I think what we're going to do is do the Pleiades, which is M45. Yeah, we're going to get in here, and these are a nice bright target, a good way to start things off. So we will get those going here. And good afternoon to you, Galaxy Spleef. Thanks for being here. Alright, plate solve on that. That should put some nice bright stars in our view, and it does. So now we will get that started. Okay, put this up here. That down here. Ooh, and I have not started all of my software yet, which is why I'm getting that error message. Okay, let's get this started. This started. You go away. You get started. And now we'll try this again. This should work a lot better this time. Hey Jeff, thanks for coming by. Just gonna start on some Pleiades tonight. So Pleiades are a pretty big, spectacular thing. It's a fairly close by object. Messier 45. Pleiades. Alright, getting close to the first sub coming in. And there's some pretty blue stars. Let's get those colors balanced and get the stretch where it needs to be so we can see some more of that goodness. Yeah, that's a little bit better. Just need a little more data to come in and fill it in a little bit. Okay. Hey Al, good evening. Thanks for coming in. The upcoming star party in Death Valley, is that a big deal? Yes, normally the Death Valley Dark Sky Festival is a big deal. And in fact, those of us who are in the Las Vegas Astronomical Society, the nearest one to our area, the nearest astronomy group to Death Valley, we usually run the star party on Friday and Saturday nights. And well, that thing went way out of whack. So we usually run the star party on Friday and Saturday nights. So yes, normally I am there, and it's a great event. I love it. It's kind of like my local event for the Las Vegas, for the star parties that the Las Vegas group holds, because Las Vegas is 80 miles away, and they come out to Furnace Creek, which is kind of in my backyard a little bit, and so it's kind of my local thing, and so I love doing it. But boy, the weather forecast is just looking bad. In fact, I basically had to beg off and give up my registration because just nasty storm is moving in. The weather we got last night and tonight is really what we needed for the weekend, and instead it's happening now and not on the weekend, and so we got some really bad weather coming up. It's going to be they're talking 40 plus mile an hour wind gusts Friday afternoon and evening, and then again Saturday afternoon, tapering down a bit but not nearly enough by Saturday evening, and rain showers on Saturday and Saturday evening too, to boot. So not a whole lot of fun. So this year I don't think it's going to be a big deal, but yeah, normally it is. It's fun. It's an event I love doing, and usually we get a decent amount of people who come through as well. We'll get 1,400 or more people coming through over the course of the weekend. So it's a pretty big event, and it's usually a very cool thing. The nighttime star parties, the lectures. On the afternoon, midday on Saturday, they do solar observation out in the patio, and so it's a very cool thing. But this year the weather is not cooperating. So yeah, I don't think it's going to happen this week. I don't think it's going to happen this year, which is unfortunate. At least it's not going to for me. I doubt anybody much is going to show up. There will be, of course, people in Furnace Creek because there'll still be tourists and things enjoying the sights. But unfortunately, the Dark Sky Festival is not. The weather is not cooperating. So, which I am bummed about. But at least I get to be here with you tonight on a very fine evening, and looking at some cool stuff. In fact, we can make this a little bit bigger. No, I can't do that because then you can't see everything. Oh well. Okay, so what do we know about the Pleiades? It's also called the Seven Sisters, or Messier 45. It's the 45th object in Charles Messier's list of things that were not comets that he kept seeing as a comet hunter. So he made a list of things so you'd stop thinking they were comets. It's an open cluster containing middle-aged hot B-type stars in the northwest of the constellation Taurus. It's about 444 light years away. I wonder how they get it that exact. It's among the nearest star clusters to Earth. It's the nearest Messier object to Earth and is the most obvious cluster to the naked eye in the night sky. It is also observed to house the reflection nebula, NGC 1432. What we're seeing mostly is, that's a lot of that, the reflectivity, the nebulosity in there is a reflection nebula, but it also contains NGC 1432, which is a hydrogen beta region, which is an emission region. The cluster is dominated by hot blue luminous stars that have formed within the last 100 million years. Only 100 million years old, and it says they're middle-aged hot B-type stars. Well, I guess those hot B-type stars must burn themselves out pretty quickly. That's probably what they do. The reflection nebula around the brightest stars were once thought to be leftover material from their formation, but are now considered likely to be an unrelated dust cloud in the interstellar medium through which the stars are currently passing. The dust cloud is estimated to be moving at a speed of approximately 18 kilometers a second relative to the stars in the cluster. So we will see this nebulosity change over long periods of time. 18 kilometers a second is pretty fast until you consider the distances and sizes of things. So Still take a while before we'd notice much. Computer simulations have shown that the Pleiades were probably formed from a compact configuration that resembled the Orion Nebula. Astronomers estimate that the cluster will survive for about another 250 million years, after which it will disperse due to gravitational interactions with its galactic neighborhood. So only 444 light years away. But it's a pretty way to start off the evening. I like starting on it just before the sky gets fully dark, which it's just about getting fully dark now. But a nice big bright object that shows well even in a not quite fully dark sky. And as always, my internet will be a little flaky here and there, so the picture may jump now and again and whatnot, but mostly I got a pretty solid signal out here. Yeah, I think it was pretty murky when I 2 weeks ago when I was out here, huh? I think it was pretty murky. I think we had a lot of humidity in the air and the transparency wasn't so good. But tonight it's really nice. It's really quite nice. Still not perfectly crisp, but it's definitely favorable conditions. How is it down in Arizona tonight, Al? You far enough east where you're still in the tropical gunk, or have you got some decent skies tonight? You can see a lot of nebulosity extending around things. It's quite a nice looking object. Thank you to whoever hit the thumbs up. I appreciate that. Nice to know you're enjoying the show. Yeah, it's just a lot of cool dust clouds in there. Oh, I know what I forgot to do. I forgot to turn on the background music. little bit, we can see where we'll go next. I think most of Orion has probably crossed the meridian by now. Yeah. Lots of cool stuff to see in here. Yeah, lowers there. There's still a bunch of stuff that has to come across yet. But, yeah, that stuff's all gonna wait for a minute. Might try M78. Let me know if you can hear me okay. I noticed that last time my audio was low last time from my microphone. I got to keep my microphone much closer to my mouth so that I can be heard. So let me know if let me know how my audio is. Huh, good. Thanks, guys. Yeah, I didn't have my mic close enough to my mouth last time. And it had just been so long since I've done one of these that I just forgotten a few things. So, hopefully doing better. Hopefully doing better now that I've done a couple here. Getting back in the swing of things. So. Hi, Pamal. Welcome. Thanks for stopping in. As you can see, we've started with the Pleiades. Actually, now that I got a bunch of people here, I should probably show you guys what I'm using. So, here is my setup. It's set up in my backyard. It's a 6-inch f4 imaging Newtonian mounted to a ZWO AM5 mount, and so it's a Newtonian reflector telescope that's running on this little mount right here, and that's what drives it around the sky and moves with the sky as it takes exposure. So the blocks are all glued together, but the blocks are not glued to the pad, so I can still move it if I need to, but the blocks are all glued together, so it makes a good solid sturdy weatherproof pier that I can use year-round and stays outside year-round because it's weather impervious, and just the mount and the scope and everything else goes in. And I'm sitting behind this table here with a couple of laptops and talking to you guys. So that's what's being used tonight, along with a 183 MC color camera stuck in the focuser up here. So that is what I am using tonight to collect these images. So there's M45. So let's go to our next object. We'll go to something a bit smaller now. We're going to go to, so this is Orion right here, which has just crossed the meridian, which is this red line here. So it's just gone to the west side of the meridian. So right here is Orion's belt and Orion's sword, which we will be looking at all of later. But we're going to go right in here. We're going to go to M78, aka Casper the Friendly Ghost. And we're going to look at some of this because this is a pretty varied... Have I? Yes, I did. Okay, good. There's a lot going on in this little spot here. But it's a pretty cool thing to look at. It's much more faint than the Pleiades was, but there's still a lot of interesting things here to see. Okay, plate solved and recentered. Now we'll get everything going and start. Start taking our first image. So this is M78. Well, part of it is M78. It's actually a few different things going on in here. It's a reflection nebula. It's in the constellation of Orion. It was discovered by Pierre Machin in 1780. And included by Charles Messier in his catalog of comet-like objects that same year. And again, Charles Messier was an astronomer back in the 18th century, obviously, and he was a comet hunter. And he liked combing the skies for comets, and he kept seeing these objects that were, that he wasn't sure were comets, and then he discovered they weren't comets, and so he started cataloging a bunch of objects that were not comets so that he would know to not waste any more time on them. And in doing so, he compiled a list of some of the brightest, most spectacular objects in the sky that we now call the Messier list. And it's a catalog of what's now 110 objects. 102 or 3 were actually what he published, and the last several were added posthumously by researchers who went through his notes and realized he discovered the extra 7 or 8 at the end. He had discovered them, but just hadn't officially, formally published them in his catalogs. So they posthumously added numbers 103 to 110, I believe it is, and so it's now 110 items long, and it's just one of the most spectacular lists for amateur astronomers to look at. They're just wonderful things. And so this was item number 78 on his list. So that's what we're going to be looking at now, is Casper here. We'll see how well we can bring it in. Kevlu asks the approximate cost of your equipment. It's quite a range, actually. Everything from cinder blocks, which, cost nothing, to, this little mount right here was a couple $1,000s, but you do not need to do something like this to get started. I was on mount that only costs about a third that much, which before I upgraded to this, but it doesn't take that much. This telescope is about $300 on the used market. That's not bad. My camera is about $650 or so that I'm using tonight on the used market. I am running a coma corrector in it. That's another few $100s. So yeah, I mean, it does add up, but you know, it doesn't have to cost $1 million to be able to see some interesting stuff. So it's, you know, spendy by some people's reckoning and not so much by others. But yeah, I don't spend a whole lot of stuff. I don't spend a whole lot of money on my equipment. But over the years, I have upgraded and upgraded and upgraded. And I've been doing astronomy on and off since I was a kid. Since my parents bought me my first rickety Sears refractor back in the 70s, and you know, it was rickety, and you know, it's the slightest breeze and everything shook all over the place, and you know, so it was frustrating to use, but it got me totally hooked. And so I've done it on and off throughout my life, kind of. And just in the last 4 or 5 years, I've been doing what's called EAA, Electronically Assisted Astronomy, where you're actually using cameras to assist your ability to see these objects. And so I've been doing that about 5 years now. Oh, come on, you. Ooh, you're not going to cooperate. All right. And so, yeah, it's been about 5 years that I've been doing that. So, that's been a lot of fun. But, you know, so over those years, I have slowly upgraded and upgraded and upgraded things. But it's I still haven't spent a ton of stuff here. Okay, Al says he's clouded in, and we will get your weather after you. Yeah, you guys are usually a day or two behind us because it moves east. So yeah, there's some good stuff coming. But yeah, sorry you're still in the gunk. I will be studying Messier objects in the lab class during the last Planetarium lab. That's good. Messier objects are a lot of fun, and for most, you know, because they're such a popular list, most clubs, that's one of the lists that new people start off with, viewing all 110 Messier objects, checking them off one at a time as you view them. And there's even something called a Messier marathon, which one point in the year, very end of, usually somewhere in March, about a month or so from now, a couple weeks, things are just in sort of the right position in the sky where it's actually technically possible to view all of the objects in one night. And it's called a Messier marathon. And various people have attempted, and some succeeded and some have failed. Yeah, so that's another thing you can do with a Messier list, although I doubt Pamal's going to have you guys do that. That's probably the advanced class. But no, the Messier list is a fabulous list of objects. It is really a lot of great stuff in that list. So, okay. Welcome, Anna. Thanks for stopping in. Thanks. Sounds like you can easily turn into a rabbit hole. Oh, of course, Kev. Yeah, I mean, any hobby can do that, and this is another one of those hobbies where you can sink as much money as you don't have into it. So, you know, at some point you just gotta realize, okay, this is good enough, and you know, and stop spending money. You know, so, and when I reach that point, I'll let you know. But it's definitely one of those hobbies where you can spend a lot of money if you want. So it can be the bottomless pit. Oh, sounds like you guys got homework. Take notes and make sketches. Sketching is such a great way to do astronomy. Some people do sketch. Some people just take text notes of what they see. Some people actually sketch things. The nice thing about sketching what you see, either in the telescope or whatever, is it makes you see more. It forces you to actually see more than what you would have seen if you were just sitting there looking at it. So sketching is a really great way to do astronomy. And a lot of people have done it that way. Let's see. So anyway, where were we on this? M78 is the brightest diffuse reflection nebula in a group of nebulae that includes, and you see 2064, 2067, and 2071. This group belongs to the Orion B molecular cloud complex and is about 1,350 light-years distant from Earth. It's easily found in small telescopes as a hazy patch and involves two stars of 10th and 11th magnitude, which are, I believe, right there and right there. A little bit blown out right now. Could back off on the stretch a little bit here. We'll be able to see the stars a little. There we go. So we can see the stars a little bit better. So, actually, it may be these two stars they're talking about. But now you can kind of see the stars a bit better. But the nebulosity is kind of backed off a little. 10th and 11th magnitude stars. These two B-type stars are responsible for making the cloud of dust in M78 visible by reflecting their light. Let's zoom in a little bit. See, there's even two in here. I don't know if my annotation... Let me do a quick plate solve and see if my annotation will pick up those stars. Not sure that it will, but give it a shot here. 2071. Oops, come on, you. Yeah, see, so this is 2071 here. Yeah, an M78 is the one up here. Yeah. So that's a different cluster. So the two stars that it's talking about must be these two here. No, I guess no. Actually, it could be. It's these two. These are the two eyes. I believe this is why they call it Casper, the Friendly Ghost, because it's got these two eyes in it. So these here are the two stars that it's talking about. These two little stars right in here. And then this one is just a third star that's off there. But yeah, these are the two stars here, the 10th and 11th magnitude stars, and they're making all of this gas and dust glow. And it's called a reflection nebula because they are actually reflecting the light of these stars. As opposed to a dark nebula, like up here, which creates these dark lanes, which is basically just dark gas and dust that's either non-reflecting or between us and this cloud that's behind it, and so it's blocking the light. And so that's a dark nebula. And then the third kind is an emission nebula, which is gas and dust that is being irradiated by certain kinds of stars, and it's actually because it's irradiated, it's ionized and actually producing its own light. It's actually emitting its own light, and so that is the third kind of nebula, which is an emission nebula. In this case, we're looking at just the reflection nebula, 2067 here. Okay, get that out of the way. You can see there's a lot of interesting dust clouds. You have the dark nebula is blocking out some of this stuff. So this is all dark nebula area in here. The light cloud is all behind it probably, and this is all dark nebulas between us and this light cloud, or just kind of going through the the light cloud, the cloud that's being reflected by the stars. It's probably that this is closer to us and just blocking the light from this reflection nebula partially. Oh, and we got a satellite that just zipped through, as they often like to do. Oh, a second one over there. Did we say this was 1,350 light years away? Yeah, I think it's about right. Yeah, 1,350. So the light we're seeing from this right now left it 1,350 years ago. So astronomy is looking back in time, because we can only see what the object looked like when the light left it. And the distances in space are so vast, and it takes so long to get here that we don't have any idea what it looks like today. Chances are it looks pretty darn similar, but who knows? Could have all blown up by now 1,000 years ago, and we still won't know for another 350. So it's really like looking back in time, because the distances are so vast. So not quite as big and sexy as Pleiades, but still a very interesting part of space. Interesting part of the Orion molecular cloud. Well, that's just a huge, and you can see there's red out here. I mean, hopefully you can see that on your screens. There's just red out here. The entire area of Orion, this entire area, so this whole constellation here, this whole area, they call it the Orion molecular cloud. Just massive area of dust and gas, and lots of star-forming regions, some of which we will take a look at tonight. But just a really interesting part of the sky. And right now it's right almost straight up. Like I said, the red line here is the meridian, which is the directly above, and it's right at the zenith. And so this is very high in the sky, and so if you have a small telescope or even a pair of binoculars work great for viewing some of these things. And some of the things that we will view tonight, it works really well for that. And so, yeah, go out and take a look at the whole Orion area. The whole Orion region is just really, really great stuff. So now I think what we'll do is, we talked a bit about emission nebula. I think maybe we'll go look at one now. I think maybe, we got a photo bombed by a satellite right through Casper. But there's Casper anyway, Messier 78, and an interesting little area. Let's go look at an emission nebula next. And this one's going to be up here, so I've got the above Orion. It's going to be right here above Orion's long arm. So right up here, it's going to be, alright, you, get in there. It's going to be the monkey head, or NGC 2175. Alright. And that should be pretty close in there. I don't know if I can actually select. If I select Monkey Head Nebula 2175. Yeah, see, they call it an HII, or hydrogen beta region, which is an emission nebula. And so this one's going to be a red area. Most emission nebulae are hydrogen, and so they're red in color, whereas blues and greens in nebulae tend to be more oxygen-y, but unless they're reflection nebula. But in this case, yeah, there he is up there. Let me over, flip, move, yeah. So you can see he's kind of like a monkey skull, kind of like he's looking up, looking straight up. Let's get those colors balanced a little. Get this moved a little bit, stretch it a little more. And yeah, now we'll just spend a little time collecting some data on this. So this is an emission nebula. And let's go and see what NGC 2750. Oh, what is it? 2174. Oh, it's 2174. It's different from the cluster, of course. 2174. Emission nebula in constellation Orion. NGC 2174, also known as Monkey Head Nebula, is a hydrogen beta emission nebula located in the constellation Orion, and is associated with the open star cluster NGC 2175. So the nebula and the star cluster that's in it have different NGC numbers. And NGC, by the way, stands for the New General Catalog. And it's one of the bigger catalogs of stars, the bigger popular catalogs of stars that astronomers use to identify objects. It's thought to be located about 6,400 light years from Earth, so quite a bit further than what we've been looking at up to this point. The nebula may have formed through hierarchical collapse. There is some equivocation in the use of identifiers, 2174 and 2175. As to what it, there's basically some argument as to whether the numbers apply to the whole nebula, to just the brightest part of the nebula, or just to the star cluster, etc. Burnham's Celestial Handbook, which is a very popular guidebook for a lot of astronomers, both amateur and professional, lists the nebula as 2174-75, both of them, and it does not mention the star cluster at all. Glowing gas and dark dust do not survive well in the Monkey Head Nebula. Young stars near the center of the nebula generate stellar wind and high-energy radiation that causes the nebula's material to shift into complex shapes. The nebula is primarily composed of hydrogen, which glows at infrared wavelengths due to the radiation, and that's also why it's red, because of the hydrogen. So about 6,400 light years away. What makes you ask that question, Jesus? Are you seeing something out of a glow from the side of the screen or something? What makes you ask that question? I suppose we can just look here. There's nothing that's really that bright here. I suppose Propus here would be the next brightest star. So there's nothing that close to our field of view to be something very bright that's there. We do have a bright star there, and I didn't center the object really well, so so it's a little bit off, but the view just looked a little pale. No, I don't think there's anything that bright nearby. So you're probably thinking the contrast is a little bit lower. Background sky is a little brighter here. And part of the reason that the background sky is brighter here is because we're kind of in the Milky Way. So if you I don't know if you guys can see this on your screens, but there's a band right here, a bright band that goes right by Orion. So there's Orion right, and that's a little beautiful. Here's Orion right there, and then there's this light band that goes right through here, and that is the Milky Way galaxy. And so that's basically an arm of the Milky Way, and this is us looking at an arm of the Milky Way as it's extending away from the center of the galaxy. In the wintertime, we are looking away from the center of our galaxy. In the summertime, when we're looking at the Milky Way, we're looking toward the center of our galaxy. And so right now, we are looking at the outer winter arm of the Milky Way galaxy here. And the monkey head is right in the middle of it. So it's a really dense field of stars. And so when you look at this image compared to the Pleiades that we had seen, and even M78, which Orion is kind of off, just a little bit off the most of the Milky Way band. So you can see it darkens up a lot by this point where M78 was. But when we're talking about monkey head, it's much more in the thick of the band of the Milky Way, an arm of the Milky Way. So you're seeing a lot more background stars from the arm of the Milky Way that are in this image, so it makes it look like there's not as much contrast, and the background is lighter and less contrast for the object that we're looking at, in this case the Monkey Head Nebula. So we've seen all three kinds of nebula so far tonight. I don't know if they consider some of this part of. Let's see if they consider some of these dark lanes and areas dark nebula as well. They could. It doesn't look it. Looks like they just consider the whole thing the monkey head. This they consider an open cluster. Yeah, I don't think they No. Let's get rid of that. Oh, come on. Yeah, they don't consider anything in here dark nebula. So I guess this is, like they said, like Wikipedia said, it's just the radiation, the solar wind from the stars that are in this nebula are just blowing it into interesting shapes. And it's not that there's any dust or whatever dark nebula that's in front of it. It's just the way the stars are blowing it around. Actually, looks like there might even be a little bit of reflection nebula in here, because see, we've got some of this fuzzy stuff that's much paler right here, and then another really fuzzy spot here. It almost looks like it's reflection nebula. It's not hydrogen, and it's probably stars that are in or around these two little sections that are actually causing a little bit of reflection nebula to happen, I think. We'll take another couple of minutes on this. What are we going to do? We'll go to maybe we'll go down deeper into Orion. Another one I want to do is out here. It hasn't crossed yet, so maybe we'll go do Alnitak. The Alnitak region is next. But we'll take a last minute or two look at the monkey head before we move on. Pretty star clusters in there, though. There, I got this nice line of stars there. Like I said, I've never noticed these puffy parts before. That's the first time I really noticed those. Those are kind of interesting. Thanks for asking, Al. I am just using a UV-IR cut filter on my camera tonight. So different filters can do different things when you put them on your camera. Just like for regular photography, astrophotography, you can filter out certain wavelengths, and if you want to just go after one particular kind of thing. And so tonight I'm just using a filter that basically cuts out the extreme edges of the visible band, the ultraviolet and infrared sections. It basically cuts out the very end of the visible spectrum. It just gives the fat middle part of the spectrum of light. And the reason for that is that infrared, the focal point of infrared can be slightly different from the focal point of the rest of the light spectrum, and so it can actually make your stars look a little bit fuzzier and more bloated if you have any refractive elements in your optical train. And so In my case, I have a reflector telescope, but the coma corrector has a number of refractive elements in it, so I still use a filter that cuts out the UV and IR portions of the light just to sharpen things up a little. It also tends to make the star colors pop out a little bit better. So that's the only filter I'm using tonight. This is called a UV IR cut. Okay, so there's the monkey head. And now let's head over to the Alnitak region, which is always one of my favorites. And the Alnitak is the left-hand star in Orion's belt. So again, here is Orion, and here we are going to go look at what is around Alnitak itself. And so let me get this, move that into there, and that should have things, yeah, it should be right about right. Okay, let's get started on that. Boom. Okay, while that's going, Golden Phoenix asks, what's the FOV of your camera image? My field of view is 1.1 degrees tall by 1 2/3 degrees wide, according to astrometry.net. So, a bit under 2 degrees wide and just a little over 1 degree tall. So, in the Alnitak region, we're going to see a couple of different nebulae, which actually are both still going to be emission nebulae, but they're going to be different colors. And one is called Flame and one is called Horsehead, and you're going to be able to tell why in a second here. And they are surrounding a very bright star called Alnitak. And let's back this off just a little bit initially. Got the noise, knocked some of the noise down. But this here, this is Alnitak. So this is the left-hand star of in Orion's belt. And the rest of the belt is kind of up here to the upper left, diagonally heading to the upper left here. And so here are the Flame and Horsehead Nebula. And I think you can tell why they each have those names. There you go, ALNI. Yeah, Golden Phoenix has it right. It is actually, you can't see it very well. ALNITAK is correct. Yeah, Golden Phoenix had it correct. Yeah, and so that is, so the three stars in Orion's belt are Alnitak, Alnilam, and Mintaka, respectively. And so these things just surround Alnitak, which is the left-hand star in Orion's belt. Yeah, thanks, Jesus. I agree. This is one of the nicest things. It's just, and they're nice objects, and there's a nice color variation between them, and it's a really nice object. And they also happen to fit very nicely in my field of view. I could have gone up a little bit higher with it, but it's okay. Only get a 20 by 15 arc minutes. Yeah, that's a quarter degree by quarter degree. That's a tough thing to do, because it's hard to find stuff when your field of view is that small when you're using a camera. You know, obviously a bigger sensor makes things a lot easier to see because you can see a lot more. It makes it easier to find stuff. But you know, obviously, as you go up in in size on a sensor, they amplify and magnify in cost quite quickly. It's said the 3 main pyramids in Egypt aligned with the 3 stars. Oh, I didn't know that. Yeah, it's 75x. Yeah. Look at that. We got photobombed by a satellite. Went right through Alnitak. Gave me 5th and 6th diffraction spike on Alnitak. And that's what we're going to be doing for the next couple of months, is going to be galaxy season, because the winter Milky Way is going to be getting lower and lower in the western sky, and so we're going to need to have something to do, and so the galaxy season comes right in to fill the gap, basically. With all those pesky Milky Way stars out of the way, we can see extra galactically much more easily, and so we see a whole bunch of galaxies. And in fact, you can kind of see on in my Stellarium here, the red circles are galaxies, and so this is the winter Milky Way, which is going to get more and more westerly as time goes on, and then we're going to be doing some galaxies. So here's what's rising in the east. All these are all galaxies, and this is the smallest of fractions of galaxies that are now low in the eastern sky, but they're going to be getting higher and higher and higher each month. And so we're just going to spend a lot of time looking at all these galaxies. Look at all the red circles in there, and there's many, many, many more than that. So yeah, you could spend a lifetime looking at galaxies and never ever run out. There's literally billions of them. Down to magnitude 16.5. Yeah, well, it's depending on how well you said you have a CCD imager. I don't know if that's mono or color. My camera is mono. Even with my color here, with this setup here, I can see stuff down to mag 18 or so. Maybe even a titch more here or there. Every once in a while I'll get a mag 19 or 20. But I can see at least down to mag 18 with my current setup. So yeah, you can see pretty faint small things. I mean, it's just, you know, you go longer with exposures, you'll be amazed at how much stuff you can see. All right, so let's see what Wikipedia has to say. The flame. So I looked up the Flame Nebula, which obviously is this down here. This is the flame down here. So I just looked up the write-up for this, and it says it's an emission nebula in Orion. It's about 900 to 1,500 light years away. Apparently, they're not sure. The brightest star, Alnitak, the easternmost star in the belt of Orion, shines energetic ultraviolet light into the flame, and this knocks electrons away from the great clouds of hydrogen gas that reside there. Much of the glow results when the electrons and ionized hydrogen recombine. Additional dark gas and dust lies in front of the bright part of the nebula, and this is what causes the dark network that appears in the center of the glowing gas. So, yeah, this stuff is actually, unlike the Monkey Head, which didn't seem to have any dark nebula making its shapes and features, it was just solar winds doing that. This actually is, let's zoom in on this. this actually is dark nebula that's in here. That's just dark dust and gases that are between the flame nebula and us, and blocking the light from it. But they give it this interesting flame-like look. This kind of cool structure in here. At the center of the flame nebula is a cluster of newly formed stars, 86% of which have circumstellar disks. X-ray observations by the Chandra X-ray Observatory show several hundred young stars out of an estimated population of 800. X-ray and infrared images indicate that the youngest stars are concentrated near the center of the cluster. Wikipedia has a picture of this, where they combined basically X-ray and infrared images, and it looks nothing like this. But yeah, apparently there's a cluster in here somewhere, probably mostly obscured by this the dark nebula here. But thanks for joining, Golden Phoenix. See you next time. Thanks again for the for spending time. Appreciate it. Just a cool looking nebula. And now its partner in crime over there, the Horsehead Nebula. Let's go take a look at that one. Come on. There we are. So here's the Horsehead. It's a small dark nebula in the constellation Orion. The nebula is located just to the south of Alnitak, the easternmost star of Orion's belt, and is part of the Orion molecular cloud complex. It appears within the southern region of the dense dust cloud known as Lynn. I was taking longer exposures on this, which we don't want to take the time to do tonight, but this actually extends up quite a ways. So this IC434 is all the red hydrogen beta emission cloud, and the Horsehead is basically a dark nebula that is blocking out light from the IC434, and it just happens to have this really cool Horsehead shape. So it's actually two nebulae, whereas the Flame Nebula is all considered one thing, the light part and the dark part. This is actually considered two different nebulae because the dark part makes such an interesting shape that it has to be called the Horsehead. So this is actually two nebulae that are there. It's approximately 1,375 light years from Earth. It's one of the most identifiable nebulae because of its resemblance to a horse's head. It was discovered by Wilhelmina Fleming in 1888 on a photographic plate taken at Harvard. One of the first descriptions was made by E. E. Barnard, describing it as dark mass, diameter 4 arc minutes, on nebula strip extending south from Orionis, Lambda Orionis, cataloging the dark nebula as Barnard 33. But a very pretty region that fits within my field of view quite nice. So I like imaging this part of the sky, even with the glare of Alnitak there. These really just pop out very nicely. I could probably stretch this a little bit more. Brighten it up just a wee bit more so you can see a little bit more of the nebulosity. Yeah, if we took longer exposures, this would really pop out up here. Alright, while that's doing that, let's see. Is my next target clear yet? Yes, it is. Okay, we're going to next head for the Rosette Nebula, which is another really cool mixture of emission and dark nebula and star cluster, and another beautiful thing, again, right around Orion. So there's the Alnitak region, with photobombed satellite, of course. All right. Let's go to the Rosette. Puts us back on the close to the meridian here. We got a nice star cluster that'll be zipped right in the middle of the screen by the plate solving, and then we can get a start on that. Here's another one that almost fits perfectly in my field of view. It's actually a little bit too big, too big for my field of view, but it comes darn close. Okay. Rosette Nebula. It's also a hydrogen beta region located near one end of a giant molecular cloud in the Monoceros region of the Milky Way galaxy. So I guess they consider this is not Orion, but this is actually part of Monoceros here. But again, it's still, I think it's still part of the cloud. So this is all just one big area of region of dust and gas, star-forming areas. The open cluster NGC 2244 is closely associated with the nebulosity, the stars of the cluster having been formed from the nebula's matter. So the star cluster that we're going to see in the middle here, so this star cluster here is actually formed from this nebula. So this is also a star-forming region, which there's a lot of those around Orion. So, and you can see there's a lot of hydrogen in this because there's a lot of red, and also you can see some interesting dark spots too, some Bach globules and just some dark nebula that also make for some interesting shapes. And after we collect a few sub-exposures here, we'll zoom in a bit and look at some of the areas more closely. But this is, the Rosette, or NGC 2244, or Caldwell 50. It appears in several different catalogs. It's such a very cool object. So yes, this star cluster formed from this nebula. Over time, gases coalesce and form balls, and The bigger the ball gets, the more gravity it has. So the more gas it attracts to it, which then attracts more gas, which then attracts more gas, and eventually it collects a massive enough amount that it actually crushes in its own, under its own gravity, and the star sparks to life. The nebula has been noted to be having a shape reminiscent of a human skull and is sometimes referred to as the Skull Nebula. But the Skull Nebula actually, there actually is a real Skull Nebula that actually looks a lot like a Skull Nebula. So it's not, I don't think it looks like a skull myself. I mean, yeah, well, it's something this size. You can get, you know, you can look in this and see all kinds of stuff. It's like, you know, lying on your back on the lawn and making shapes out of the clouds. You know, there's a, you can, with imagination, you can make almost anything happen. So there's a lot of stuff you could see in here. I don't get a skull, but there's all kinds of different regions where you can see various shapes and sizes of things. This is about 5,000 light years away and is about 130 light years in diameter. The radiation from the young stars excites the atoms in the nebula, causing them to emit radiation themselves, producing the emission nebula we see. The mass of the nebula is estimated to be around 10,000 solar masses, which means about its mass is about 10,000 times our sun. Oh, Pamal can see the skull. Well, you'll have to show me someday where that is. I don't see it. But and of course, when a lot of these things were named, they were not using, well, photography to do astronomy at all, much less had the sensitivity of sensors that we have now. Most of them were looking through, you know, good old-fashioned telescopes that, you know, they made themselves, or, you know, hand-ground and polished lenses on their telescopes. So, you know, they could not see they could only see a fraction of what we can see today. When you're looking at something visually through a telescope, your eyes have approximately an exposure time of 1/10 of a second. And so that's what the human eye does, about 1/10 of a second exposure, which does not allow a whole lot of light in. But, you know, now when you can hold a camera exposure, and when they started using cameras, now you can hold the shutter open, boy, for, you know, a second is even a big improvement. It's 10 times the light, 30 seconds, 300 times the light, a whole minute, 600 times the amount of light. You know, so as you hold the shutter open for longer and longer, and we're doing 60-second exposures here, you just collect more. And so what we can see today is so much more than what they could see then, when they were actually first discovering and cataloging these things. And so you know, we see so much more of it that it just messes up what they could see then. And you know, they could probably only see 1/10 of what we can see here. They probably saw the cluster pretty well, and maybe the very brightest parts of the nebula, but not the dimmer stuff and the extended parts that we can see today. Some of these dimmer, more diffuse parts on the outside, even some of these thinner parts on the inside they may not have been able to see. we got enough subs now that we can everybody zoom in and take a little bit of a closer look at some stuff here. See, as you get closer in, there's all kinds of interesting shapes and dark spots and bright glowy stars that are fairly young because they just got formed there. These are pretty interesting here. Probably see animal shapes in there or whatever else. So some of this stuff is, dark nebula that's in here, blocking the light from the nebula, and some of it is just, looks like, again, stellar wind that's kind of blowing all the dust. When the stars are formed and they ignite, they put out a lot of solar wind, and that tends to blow the gases and dust back and makes these interesting wave shapes. Seems to have even cleared out the center of the nebula itself. Made a hollow spot, sort of a donut. We can even just get that out of the way and kind of bring this more to the center. Very interesting looking nebula. What shall we look at next? Might spend a few extra minutes on this. We might head down to the belt. Sirius has got some interesting stuff. Dog. Orion's hunting dog. There's some interesting things in here too. Some star clusters in here. Got Seagull in here, but Seagull's a little big for my it's a bigger than my field of view. Certainly not as spectacular as Rosette or Flame, but interesting nonetheless. We could do just for a little variety. We can go do a star cluster. We can go do the Beehive. Just for a little bit of variety. Doing some, and we'll come back to doing some nebulae in a little bit. But for now, we'll go do just a regular cluster. I don't think we have any globs in the area. No. Got one way out here. M79. Straight under. It's possible. We could try M79. It's about the same height. Let's try M79. I've very rarely gotten I'll let this sub-exposure finish, and then we'll go look at a globular cluster. There are different kinds of clusters, really kind of two major kinds of clusters. One is called an open cluster, which is sort of a loose association of stars, like this here. You know, this cluster here it's an open cluster. It's a kind of a loose constellation of stars that are grouped together. So that's an open cluster. And a globular cluster is a much more dense, concentrated cluster. We'll go look at one of those next. Okay, reset that. We'll go look at M79. Oh, better turn my light on so I can see what I'm doing. Okay, yeah, right there. You can see it right in there already. So it'll just suck that right up into the middle of the screen. Boink. And then we will take a look at a globular cluster. And you can see how different it looks. In fact, I think I'm even going to back off on the exposure a bit and just do 30 seconds. Globular clusters are all stars, and as such they are much brighter objects. So they don't need nearly as much exposure time as fainter, more extended and diffuse objects need, like nebulae. They like you to spend a little time soaking up their photons. The nebulae do, but stars are very bright things. Yeah, I need to reset that. I did. I needed to reset it, and I forgot to do that. There we are. Okay. So you can see, first I have to, so you can see from this that it's a very different looking kind of cluster. It's now this M79 is a pretty small cluster. Some of them are fairly large, but you can see how this cluster is a lot more stars, much more densely packed than an open cluster. And so this is a small but good example of what an open cluster is. And there are various theories about what open clusters are and how they formed. One of the theories that I happen to like is that what we now see as globular clusters were actually galaxies, small galaxies in and of themselves, that were captured by the Milky Way's gravity well, and when they were captured and they became a satellite of the Milky Way, they actually perhaps passed through. They maybe even collided with the Milky Way. And when that happened, the Milky Way's much bigger gravity basically sucked most of their stars away and left only the core, basically what the core of the galaxy, intact. And so when we see a globular cluster like this, that what we're actually seeing is what was once a galaxy onto itself that has now become just this much smaller entity. And all the outer stars, maybe even it had arms at one point, or an extended cloud of stars, got stripped away, and all that's left now is just its original core. So that is one theory. Let me see if Wikipedia knows how far away this is. 79. It was discovered by Pierre Marchand in 1780 and is about 42,000 light years away from Earth and 60,000 light years from the galactic center. Like Messier 54, the other extragalactic globular, so this is an extragalactic globular, it is not in the plane of the Milky Way. It is an object that it's basically one of our satellites. It's a satellite of the Milky Way. It is believed to not be native to the Milky Way galaxy at all, but instead to be the putative Canis Major dwarf galaxy, which is currently experiencing a very close encounter with our galaxy. This is, however, a contentious subject, as astronomers are still debating the nature of the Canis Major dwarf galaxy itself. Messier 79 may also be part of the Gaia sausage. Gaia sausage? I don't know what that is. The cluster is being disrupted by the galactic tide trailing a long tidal tail. So it's trailing a tail of some kind. Anyway, so it is definitely extragalactic at 42,000 light years. Now the things we've been looking at have been more in the area of 4,200 light years away, and those are within our arm of the Milky Way, or a neighboring arm of the Milky Way, just a few thousand light years away. The Milky Way itself is about 120,000 light years in diameter. So the total diameter of the Milky Way is about 120,000 light years. And so, you know, these things that are a few thousand light years away are you know, within our arm of the Milky Way or within a neighboring arm of the Milky Way galaxy. And so this is now 42,000 light years away, so 10 times that distance. So this is basically a third of the entire diameter of the Milky Way away from us. And it's 60,000 light years, so half the diameter of the Milky Way away from the galactic center of our Milky Way galaxy. So it's definitely outside of the galactic plane. Which is basically there's the core and the arms, and they're all on a single plane, a flat plane of rotation. And so this is definitely off that plane of rotation, the galactic plane. And so it's standing off, and it's probably orbiting the Milky Way, and just kind of hanging with us. So anyway, this is a globular cluster. So there's lots of stars in there. I have the wrong type of telescope to be able to really resolve sharply any of the stars. Mine is really designed to collect faint fuzzy objects like nebulae and stuff, and even galaxies, even entire galaxies. But to really resolve this type of object well, takes a longer focal length telescope, and ideally even a refractor. Refractors do really well with the sharpness of that are required to do stars, whether you're, you know, splitting double stars or looking at globs or open clusters or whatever, or even just doing photometry. Refractors tend to do better on stars than my scope here, but still it's good enough to be able to see what a globular cluster is. So let's see, anything else interesting down here? I suppose we're down here, we could take a look at a galaxy. I don't know what mag 12, mag 15, that's a little dim. Where am I? I'm out here, and I don't want to go any deeper out there than 11.3. Yeah, so now I'm just kind of poking around at these 11.3, 12.3. Here's an interacting galaxy. It's pretty dim. Interacting galaxy means two galaxies interacting with each other. So mag 11, what's this one? This is mag 665. This one's brighter. So we'll try doing this one. We'll just to do, again, something different. Good night, Pamal. Thanks for coming in. And I hope you enjoyed it, and I hope your students did too. Hopefully you do some, be able to have some good conversation in your next class. But yeah, good night. Thanks for coming. We're going to go look at an interacting galaxy next. So let's go look at that, because we just haven't seen any galaxies yet tonight. So just for the heck of it, let's go look at not just a galaxy, but an interacting galaxy. Oh yeah, see? The Stellarium has a actual picture of it. Well, let's see. Let's see what we can see. Alright, let's plate solve and center that up. Oop, come on, click. Alright. And then we'll get started. Alright, so this is going to be 2207. Let's see what Wikipedia has to say about, and you see 2207. Pair of colliding spiral galaxies. Alright, so these are both spirals and they're colliding. NGC 2207 and IC 2163 are a pair of colliding spiral galaxies about 80 million light years away. So now we've jumped a whole order of magnitude further again. We've gone from 4,000 light years to 42,000 light years, and now we're talking 80 million light years away to pick up these two little guys here. So normally I use my monochrome camera to do this kind of thing because they're it's more sensitive, but even with the color camera we should be able to pick out some detail here. So the larger spiral, NGC 2207, which obviously is the top one here, is classified as an intermediate spiral galaxy. In fact, I think I'm going to, stars look a little ovally on this. I think I'm going to actually, I don't think the mount was quite settled when I took that first sub. So, yeah, it's a little better. So the larger spiral, NGC 2207, the top one here, is classified as an intermediate spiral galaxy exhibiting a weak inner ring structure around the central bar. The smaller companion spiral, IC 2163, is classified as a barred spiral that also exhibits a weak inner ring and an elongated spiral arm that is likely being stretched by tidal forces with the larger companion. Both galaxies contain a vast amount of dust and gas and are beginning to exhibit enhanced rates of star formation as seen in infrared images. NGC 2207 is in the process of colliding and merging with IC 2163, but unlike the antennae or the mice galaxies, they are still two separate spiral galaxies. They are only in the first step of colliding and merging, with 2207 being in the process of tidally stripping 2163. Soon they will collide, probably looking a bit more like the mice galaxies. In about 1 billion years' time, they are expected to merge and become an elliptical galaxy or perhaps a disk galaxy. Galactic collisions are kind of interesting because even though it looks like, you know, there's hundreds of millions, if not billions of stars in each galaxy, there is so much distance between each individual star in a galaxy that even when two galaxies collide, it is extremely rare for two stars to actually physically collide. There's so much distance between them that two galaxies can pass right through each other and there's no actual physical contact. All of the contact, quote unquote, all of the impact one has on the other is simply tidal. It's simply gravity. The gravity well from each one of the stars actually impacts the other and they tear each other apart and eventually settle out and combine into one galaxy, which is what these are probably going to do over the course of the next 1 billion years. And so it's kind of interesting when they collide because they don't usually actually hit each other. They usually just tear each other apart due to gravity. Oh, I don't have this adjusted right. That will help. That will help quite a bit. yeah, you can see sort of the bar in this one and the bar in this one. And they're just in the very beginning of getting busy with each other. Should be able to see more. In fact, I'll probably even stretch this a bit more. The risk of it, yeah, it's going to have to be back here. At the risk of it being a little bit pixely. Just need to collect more subs to get it, just to smooth out a bit. Not sure what you mean by your question, Jesus. Is there a visual difference? What do you mean by that? Well, that's a good question. When two galaxies collide, obviously they combine their stars, and so depending on how their gravity impacts each other, they're not even sure what the shape of this is going to be. As as the write-up said, it's what they say it was going to be either an elliptical or a disk. An elliptical is basically just a round blob, or it could flatten out in a disk where it has an actual galactic plane like the Milky Way does with arms and stuff. But I would assume it would be bigger because it's basically combining the stars from both galaxies into now one bigger galaxy with more gravity. Yeah, I guess it would be bigger, but then again, if it turns into just an elliptical galaxy, which is just basically a spherical type of galaxy, It could be just a dense sphere of stars. It could actually, from a distance look like smaller in terms of its diameter, even though it has more stars. Whereas these galaxies right now, if you look at these two, just form a ball of stars, kind of like that elliptical, or kind of like that globular cluster, just an elliptical galaxy is just sort of a ball of stars. So even though it has more stars and would have a lot more mass afterwards than either one had before, they could actually visually look, I guess, smaller. So it depends on what shape it's going to be when it finishes colliding and figures out what its gravity well is going to be and how it's going to look, and probably will just be a ball. But for a while, it's going to have some really wild and interesting shapes. The two may, the two cores may come together and pass each other and then rip each other apart and splay stars all over the place, and it can look, interacting galaxies can look really, really interesting. And there's a whole bunch of them up there in the sky. If you get Stellarium, which is what I'm using here, the Stellarium indicates interacting galaxies by a blue circles, and what is it, the orange? It's an active, what they call an active galaxy, which means a lot of star formation, I believe. And then the red circles, there we go, there's a red circle. So over here we got a red circle, that's just a regular galaxy, and then the blue is an interacting galaxy, and this sort of orangey color is the active galaxies, which have a lot of star formation. So, there are lots of interacting galaxies up there where two galaxies have come together and they're either in the process of tearing each other apart or settling out from having torn each other apart. And, so there's lots of different ways that they can go. Sometimes it comes down to the relative sizes. If one is much bigger than the other, then the bigger one may not change a whole lot in its size and shape. Kind of like dwarf galaxies in the Milky Way. The Milky Way tends to tear the dwarf galaxies apart and strip their outer stars, leaving just a core, which is what we call a globular cluster. But the Milky Way, because it's so much bigger, doesn't really get all that impacted. So there's just so many different ways that so many different combinations of how it can happen that who knows. I'm sure they have computer models that attempt to guesstimate what will happen over the course of hundreds of millions or billions of years as these stars, as these two galaxies here collide. There are theories that it'll be either an elliptical or maybe a disk, but they're that's a pretty vague guess, and they really don't know. All we can do is look at other interacting galaxies that are out there, and there are a lot. Like I said, if you go into Stellarium, you can see where they are. You can see a lot of them, and based on what those have done, they make computer models and try and guess what these will do. So. Hopefully that answers your question. I kind of rambled on for a while there, but hopefully that answers your question. I think ultimately the answer is we don't know ultimately what it'll look like. It's kind of a guess. Stay tuned. Come back in a billion years and you'll know. But they're starting to fill in nicely now, though. We definitely got some good stuff going on. These individual, this star, this star, this star, these here, all these individual stars that you're seeing, these obviously are in the Milky Way. These are very much in the foreground. We're looking through these Milky Way stars to this galaxy that's way, 80 million light years away in the background. These stars are probably only a few thousand or even a few hundred light years away. And so this is 80 million. So, these stars here are in our galaxy. whereas the core of that galaxy is there. There have been supernovae that have been found in both of these galaxies, so sometimes one of these will actually be a supernova. I don't believe there's any in there right now. But there have been in the past supernovae that have been discovered in these galaxies. But not right now. Are there any telescope diameters? Not sure what your question means, Potato. Can you state it in a different way? Are there any telescope diameters? I'm not sure what you mean by that. Yeah, well, hopefully, Jesus, I've gave you something useful in there. Okay, but there's... We'll take a couple extra minutes on this because it's starting to fill in nicely. But there's, these are two galaxies that are just in the first start, the initial process of colliding, of coming together, and their gravity wells will start ripping each other apart. They'll just blob together and ultimately form a whole new galaxy. Hey, Curtis. Thank you, sir. Yeah, we've been doing a whole array of objects tonight. Decided to do a colliding pair of galaxies, just to do something a little different. Spend another minute or two on this, and then we'll probably finish up tonight with little M42 and Running Man. Always a good way to finish off a winter broadcast. Those two fan favorites. Well, it could be Tesla auto drive that's driving them. Maybe a little messed up. Oops. Sorry about making your galaxies collide. I think this will probably be about the end, because I'm going to have moonrise here in about, I think, about half an hour, if I remember right. So it'll be about perfect to just finish up with M42. Well, kind of a cool little pair of galaxies. I don't know. I usually use my mono camera with the regular chroma corrector because I think it's more sensitive, but maybe the color camera at f3 is just as sensitive as the mono is at f4. I don't know. Might be an interesting experiment. Maybe I should just save this as my tester. I'm going to need to put something in here, though. No, you. And NGC 2207. Save this, NGC 2207. So when I save this, I might as well just do 20 minutes even on it since I'm almost done anyway. And when I have my mono setup out here, shoot these same objects and see what I get. If the only difference is lack of color, then, well, heck, I really don't need to be using the mono camera. Alright, there's 20 minutes even. So we'll just save that real quick. And now we'll go over and do the last object of the night, which will be another big, bright, shiny object. And for that, we'll go into the sword of Orion. Now, we've done the belt, so we did the Alnitak region, which was up on the belt. So now we're going to do the sword region. For that, we're going to do these here, which is going to be a lot of interesting stuff. Yeah, that's probably about right there. Let's just do it. Whoop. Wrong. No. Wrong one. You need to be here, then you do that, then you do this. Okay. And let's plate solve that and center it. Okay. Now this is an interesting region to try to do. We did the Alnitak region earlier, and just have one really bright star and then the nice flame and Horsehead Nebulae. Well, this is a bigger region, and it's got all kinds of nebulosity in it as well, but it's some areas are really bright, some areas are really dim, and trying to get them all to show up is basically impossible. But this is one of the most spectacular star-forming regions in our sky, the Great Orion Nebula. It's actually all three stars. If you look, the three stars of the sword aren't actually stars. They're actually clusters and nebulae. So there we are. So this is actually the three quote-unquote stars of the sword. The upper star is called Running Man, sort of like a guy running in here. And then the Great Orion Nebula is the middle star, and then the bottom star is actually this cluster down here, which I believe is called the Kolkar cluster. And you see 1980. I think it's the Kolkar cluster. Lost Jewel of Orion. Maybe the Kolkar is another name for the Running Man. Maybe I got that backwards. I don't know. Anyway. The Kolkar cluster is the upper... Okay, yeah. So it's actually up here. Anyway, so this is basically the heart of the sword of Orion. I guess I could have gotten this centered a little better. Still could. In fact, I think I'm gonna just bring it down a little bit. which of course drove my guider crazy. Okay. Come on, turn you off. That should bring it down into the view a little bit better. Of course, now it got a smeared image because it started that 60-second exposure at the top and then finished it at the bottom, so it's not going to look so good. But we have to wait 30 more seconds for a real sub that will look normal. Alright, now we should get something that looks fairly normal. There we go, now we get more of that extended nebulosity a little bit better. Back this off just a little bit, but you can see how incredibly bright the Orion Nebula is. So trying to get that to be not blown out and but still see the outer wispiness is a great challenge. So to get the middle part to not be blown out, we have to back the stretch way off. And as we back the stretch way off, all the outside parts of the galaxy of the nebula go away, but we're left with just a bright core. Ultimately, what you get in here is a cluster of stars that are in here. But when you put the stretch back to where you can see the outer nebulosity, this is so bright that all of it's just blown out. So it's a very tough thing to image because there's so much variation in the brightness. But it's a pretty special and spectacular object, and this is all star-forming region. So, again, this is where new stars are being formed at the center of all this. This blinding area here. All a bunch of new stars forming. Thanks, Curtis. Hey, Jordan. Glad to see you. Yeah, satellites are almost always an issue when you're in the Orion area. They're just... The whole Orion area is just littered with satellites. Actually, I'm kind of surprised we haven't seen one come through here yet. I must be living right. We certainly have had images earlier this evening that had satellites coming through them. When we did the Alnitak region, had a satellite go buzz right through Alnitak itself. Left Flame and Horsehead alone, but went right through Alnitak itself. Yeah, for some reason, this one has stayed clean so far, which is pretty cool. But yeah, it's the Orion region from where we are located here is the Vegas area, Vegas latitude. It's just lousy with frickin' satellites up there. Lots of them. But thanks for coming by. I appreciate you watching. I'm actually just going to be, this will be my last object, because we're going to have moonrise here probably in the next 15 or 20 minutes, which means my skies are going to start getting a lot brighter. So this will be the last thing I do for the night. But if you got here late, you can always start back at the beginning of the video and see the stuff we did at the beginning. And had a pretty good night of a lot of good objects. It's pretty much stuck to the Orion area, a couple in Sirius, but Canis Major, but kind of stuck to the Orion area. There's just so much in here to see. It's really cool that we more or less spent our time here tonight. So good time to see it before the winter constellations go away. Orion will be getting lower and lower in the sky, and now, in fact, what's going to happen in a couple of weekends, we're going to have the time change. So it's going to make things later. But for the time being, the winter constellations are up, and we're prove my luck. Yeah, well, you may have just jinxed us, right? We'll see. Got 10 minutes in, still nothing, so I'd be surprised though if we don't have one show up. I'm surprised in 10 minutes there hasn't been one to show up yet, but so far so good. So unfortunately, Jordan, it looks like this weekend is going to be crapped out. I just canceled my registration for Death Valley, because it's looking terrible. It's going to be really windy both days and into the evening, both evenings, and then sprinkles possibly even on Saturday and Saturday evening. So bummer. Won't get to see you down there this weekend, but oh well, maybe next time. Let's see, when is Cathedral Gorge? I think is next month, or is it in April? So maybe you'll come out to Cathedral Gorge. See some of the nebulosity even starting to fill in between these two objects. This whole region is just all connected. The whole thing is just filled with dust and gases and that are forming stars. A lot of these stars are new. Yeah, unfortunately, that's what it's looking like. It's just going to be a lot of wind. It's a pretty strong wind too, and it's going to be a southerly wind, which means right up the the Death Valley is a north-south valley, so it's just going to come tunneling right up there. So yes, it's not looking like it's going to be good. And even just more than your mount, you'll dust your optics, because with winds like that, it's going to be dusty as well. It's probably going to be a dust storm down there. Although we've gotten, there's been a lot of rain, so the lake in Badwater is there, so it won't be as dry as normal, but still there's be a lot of dust in the air, and not good for your optics. So you'll end up having to clean everything when you get home. But yeah, feel free to message me when you guys head out this way. I know you head out to into Amargosa Valley, so yeah, it's feel free to message me when you come out this way. Well, folks, I think that's about it for me. Moon is going to be rising here pretty soon. The sky is already starting to lighten a little bit. So I think I'm going to call it a night. Before I get a satellite strike through here, I'm just going to call it a night. Thanks everyone for being here. Hope you had a good time. And yeah, I will see you next time. The weather is, like I said, is going to be pretty crappy through the weekend. Unfortunately, because I'm going to miss the Death Valley Star Party, which is unlikely to have a star party this year with the crappy weather. But the Dark Sky Festival is probably going to be a bit of a bust, which is a bummer. But I'll be back. I'll be back with you guys again. I don't know, so who knows? Sometimes next week or the week after. We'll see. It's always about the weather. The weather and my schedule merging well or not. So thanks everybody for being here, and I will see everyone next time. Good night, Curtis and Jordan and Frizzy. Thanks, and Jesus and everyone else who joined me tonight. It's great to have you here, and I'll see you guys next time. Thanks.